Okay, let's look at how to fit using Python. You can define a function like this, basically x and all the variables that you want. Then you can do a curve fit. This is coming from the SciPy, the optimize. And that variable doesn't matter to us, but this one does. This one is basically the fitting parameter. We have three: amplitude, mean, and standard deviation. And then this basically is the in a sense an array. And I plotted out. And also we can there's another specific function is a polynomial fit, basically fitting polynomials. This is the x, y, and degree of like which order you want to fit up to. This is third order. And we have a polyn 1D. Basically, this become a function. This is a function, and you can put an array into that function. It will become a array, output array. Then you can have x fit, y fit, and then it will print. I will plot it as well. And it will output Gaussian fit the parameters and the polynomial fit parameter as well. So let's look at what we have. So so it first generates some Gaussian with some noises, using those things that we don't need to worry too much about. And the blue is the original signal, and the orange is a fit. As you can see, it fit pretty well. And here is the parameter, amplitude, mean, and standard deviation. And then we have a polynomial fit. It's a really small amount of samples, so it done its best on fitting it. It looks pretty good up to the third order. So here we go: zeroth order, first order, second order, third order. And this is the polynomial fit. This is a 1D polynomial. Those are the reference you can find. And optimization curve fit, optimized curve fit.